Today we're in section 4.7, scientific notation. Scientific notation is helpful when we have really large numbers that we're looking at. Maybe we're multiplying them or just evaluating them. Can anybody think of a real life scenario where I would have a really large number?
Buying a car.
No, think bigger. Nope, think bigger. Like I'm talking about in the billions or trillions.
Buying an island.
Yes.
Counting the people in the world.
Okay, people in the world. I think there's maybe around 9 billion. Jordan? Okay, so science, so maybe think the universe. How many stars are in the universe, Joshua?
Find out America's debt.
Okay, yes, actually, several times today we've talked about America's debt, which is also, yes, in the trillions, okay? So really large numbers or really small numbers. I'm talking like 0.0000 and it keeps on going. Just like very small numbers also can be written in scientific notation instead of having to write all those zeros. All right, so scientific notation is a shortened way of writing very large numbers. Okay, so in example 1, we have two scenarios. One where there's a really large number. The retina has 120 billion rods. Don't quote me on that. That came from your book, but I haven't actually looked that up to make sure that it's accurate information. Okay, so 120 billion rods. Here's my rule for scientific notation. I move my decimal. Well, first of all I see here is a number. I don't see a decimal. Where do I know the decimal is understood to be? At the very end, right after the ones place. So my rule says that I need to move my decimal after the first non-zero number, or to give me a value, well, basically it's and, this gives me a value that is greater than 1 but less than 10. In order for a number to be written in scientific notation, it has to be greater than 1 but less than 10. Does everybody agree 1.2 is in that range? So what I say is I move my decimal right after the first non-zero number and it gives me a number in that range. So I have 1.2 and then times 10. This base of 10 is built into scientific notation. So we know powers of 10, right? So for every place value, as soon as I get to 10, it bumps it up to the next place value. So if I were to say 10 tens, I also know that's 100, right? What's 10 100s? 1,000. What's 10 1,000s? 10,000. It keeps bumping it up. So that's why I use the base 10 system for scientific notation. So 10 to the, now I have to count how many place values I went from the old decimal, the original decimal, to the new decimal location. So I went 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you don't have to make all those squiggly marks, okay? I'm just showing it for purposes of, for one, on the recording, we can see what we're counting, and it does kind of give you a visual. But really, we can go by threes, right? The first 3 zeros, the second 3, that's 6, the third 3 zeros, that's 9, and then 10 and 11. So 11 is my exponent. My exponent tells me how many decimal places are in this number that's written in scientific notation. Now in the second one, I have a very small number, 0.4 zeros, a 1 and a 2. My process for writing the decimal number is still the same. I go to my first non-zero number and I place my decimal after that number. So it's going to be 1.2 again. Notice 1.2 is the same as the first one too. Okay, times 10, it's still powers of 10. Okay, but now, well, let me take that back. Now I still count how many decimal places did I go? 1, 2, 3, 4, 5. But now since I went the other way, it's to the negative fifth power. 1.2 times 10 to the negative fifth power. Another way that you can remember this is for really large numbers, my exponent's positive. For really, really small numbers, my exponent needs to be negative. All right, so now let's do some on our own, okay? So I want you to do the first three. These are obviously all very large numbers, so they will have positive exponents. Write the number in scientific notation. So the first one, 4.52 times 10 to the 6th power. Who got it? 10 to the 6th power, 4.52. That's not very many. What went wrong? Oh. Okay, so we went 6 places. The first 3, the second 3, that's 6 places to my new spot. Okay, 1.423. Did everybody get that?
Yes.
Times 10 to the 7th power.
Yes.
All right, good. 4.2 times 10 to the 9th power. All right. Yep, that was 9 decimal places. All right, now in the second column, I'm going to do the first one with you. We still move it to the first non-zero number, which is a 5, okay, from left to right. All right, so now we have 5.23 times 10, and we have to count. 1, 2, 3, 4, 5 decimal places to get to my new one, so it's to the negative 5th power. From where the decimal place started to where it ended up in scientific notation, I went 5 decimal places. It's a very small number, so it needs to be negative. Go ahead and do the other two. 3.21 times 10 to the how many places? Negative 4. All right, 4.2 times 10 to the negative 7. And guys, listen, this is kind of how I do it. I count how many zeros are here because that's how many place values there is. So this is 6 zeros, and then plus one more is 7. So you can count each one of them individually, or if you see there's 6 zeros and then one more is 7, it's negative 7th power. Okay? So, you know, you can do it that way. It's just I don't want to say that too much, because if you do too many of those things, then it gets confusing. Like with standard form, we do look at, okay, you add this many zeros, this and this. So anyway, you're just counting the decimal places that you moved it, and it's negative 7. Who got both of those right? Okay, good. Awesome. Example 2 now. We're going backwards. Okay, so we wrote in scientific notation in the first example, and now we're writing in standard form in the second example. So we start out with scientific notation, and now we're going to write it fully expanded in the standard form. Okay, so here's how we're going to do this. The exponent tells us how many decimal places we need to expand the number by. This does not mean how many zeros, though. If you add 7 zeros to the back of it, you're going, yes, exactly. You already have, I love how y'all like already know what to do. Okay, so no, that's good, that's fine. But here's what you're going to do. There's already how many decimal places in your number? 1. So how many more zeros do you need to make 7? 6. So you're going to just write the number 3.2 without the decimal. Okay, just write the 32. And then add 6 zeros, 3, 4, 5, 6, and then put in your commas. And that's how you write it in standard form. Okay? So now let's look at the second one. 8.69 times 10 to the 4th. Think for just a pause for a second. How many more zeros do we need to add?
2.
Because we have 2 decimal places, that means we need 2 more zeros to get us out to 4 decimal places. Do you see that? So now we write 8, 6, 9 without the decimal, add 2 zeros at the end, and now it's in standard form. I want you to do the third one now. So how many zeros did I have to add to the third one?
2.
Only 2 zeros because you had 3 decimal places already, so we need 2 more zeros at the end. So 1, 4, 7, 3, and 2 more zeros. So 147,300. Who got that right? Okay? All right, so now I want you to practice some more. Write all three of these in standard form. All three of these in standard form. Just real quick, you don't even have to write the original on your notes. I just want to do just a little more practice real quick before we move on. So we had 4 zeros for the first one. 9, 4, 3, 1, 2, 3, 4. Put in my commas. All right. What about the second one? 4, 3, 1, 2. Add 4 and put in my commas. What about the third one? 7 more zeros. 3, 4, 5, 6, 7. And put in my commas. All right, who got all three right? Awesome. Okay, now with negatives. So let's think about this logically. If it's a positive exponent, I'm making my number bigger. If it's a negative exponent, I'm making my number smaller, which means I'm moving my decimal the other way, to the left. So I can still count, how many decimal places are already there, but you've got to count it on the other side because you're moving the decimal to the left. All right, so the exponent still tells me I need to expand this number by 8 decimal places, but I'm going to the left. How many decimal places are already there? 1. So how many more zeros do I need before the 4? 7 more zeros before the 4. So 0.1, 2, 3, 4, 5, 6, 7, 4, 3. Okay? So now, since it's a negative exponent, I'm making it a very, very small number. I'm now putting the zeros in front of the number, which means I'm moving my decimal to the left. Go ahead and try to do the second two. Okay, so 0 point, how many zeros? 3, 4, 5 zeros. 5 zeros, because I do have this 1 decimal place here because I'm going to the left, so I go 1, 2, 3, 4, 5, 6. So there's going to be 5 zeros that I have to add before the 1. All right, and then I get 1, 4, 5, and 7. All right, now I have 0 point, oh, and by the way, you do have to have that first 0 in front of the decimal. Okay, how many more zeros do I need in front of the 5?
3.
Nope.
Oh, I mean 4.
4 more zeros, and then a 5 and an 8. Again, the first number counts as 1, and then 4 more zeros in front of the 5 to get me 5 decimals places to the left. All right, so that's how I write the numbers in standard form. You have a section like this on your homework. All right, example 3. Using scientific notation now to compare numbers. Okay, so now I'm going to form a comparison. 91,600, and I'm comparing it to 9.61 times 10 to the 4th power. So I need to compare these in the same format, whether they're both in standard form or both in scientific notation. It doesn't matter. It just needs to be one or the other. So because my exponent is not like this crazy huge number, I'm going to go ahead and just put this in standard form. So 91,600 stays the same. And then I go, how many zeros would I add to 9.61? Very good. 961, add 2 zeros. And which one is bigger?
The left.
The wait.
To the right.
The one on the right is bigger, so it's less than. Now, let's just say you decided to compare it in scientific notation. Let's look at it that way. How would I write 91,600 in scientific notation?
9.16 times 10 to the 3rd power.
No, not 10 to the 3rd. 10 to the 4th power. Okay? Yep, I went 4 decimal places. And I'm comparing that to 9.61 times 10 to the 4th. So, because my exponents are the same, I look at my decimal values, and guess what? It's still the same. It's still less than. So, it doesn't matter if you do it in scientific notation or you compare them in standard form, as long as I see on your quiz that you compared them both in the same format and you get the right answer, we're good.
Also doesn't matter which one.
Okay, so now we're going to order numbers using scientific notation. All right, so specifically using scientific notation. So they want us to put the numbers in scientific notation and compare them. Technically, on a quiz or a test, I'm not gonna care if you change them all to standard form and compare them and then write them back, or you write them as scientific notation. But you do need to know if your homework problem says, and I don't know if it does. No, your homework just says order them from least to greatest. So you're good either way. But let's go ahead, and since only one of them is in standard form, it would be easier to change this one to scientific notation than to change the other two, if that makes sense. So let's go ahead and write all these in scientific notation. 3.9 times 10 to the 6th. How would I write 3,800,000? 3.8 times 10 to the, and this is the part, 6th power. Okay, so we're starting to get it. It is the 6th power. 3, 6. I go 6 places. All right, 10 to the 6th. And 4.2 times 10 to the 5th. All right, so my instructions say that I look at the exponent first to determine which one is the smallest value. If there's an exponent that's different, then that's my first go-to. So since the last one is a 5, it doesn't matter that 4.2 is my largest, that 4.2 is my largest decimal value. Okay, that doesn't matter. All right, so 4.2 times 10 to the 5th is my least. But now 10 to the 6th, all right, is both the same exponent. So now my tiebreaker is to look at the decimal values. So 3.8, would everybody agree, is smaller than 3.9?
Yes.
So that one's smaller, but remember back to fractions, when we write them in order, we have to write it back in the original format, 3,800,000. So I'm going to say 3,800,000, and then obviously process of elimination would say also that 3.9 times 10 to the 6th is the largest, and I would box that in. So I ordered them least to greatest. All right, and that's how you would order numbers using scientific notation. And if you understand that, that's everything you need to know for part 1 of section 4.7. We'll cover the final example tomorrow in class.